Hey guys, Laertes here. Today I had a small thing to talk about, share one of my findings. It's something that's going to the C++ realm of working with Unreal, but I hope this will be useful to someone. Let's see. Let's create a new C++ project while I'm explaining what we're going to do. Okay, so working with Unreal, you're going to C++ eventually when you're programming some stuff and you care about optimization and all these kind of things. And being a C++ programmer, I'm not used to what is referred to as reflection system, or for some C++ programmers, RTTI. And Unreal features its own reflection system based on U classes and UStructs. And today we will dive into it a little bit. And I'll explain what this means in a second. So we've loaded our project. Let's say I have output on other screen. Let me just go like this. Yeah, that's fine. Okay. I'll put output somewhere where you can see it actually. Alright, so we have our project. If I go to Solution Explorer, I think I will find that there is no source code for now because I made an empty project. Yeah, only the project header and CPP file. Okay, so what we will do today essentially is we will be changing the properties of a structure, Unreal or UStruct, in the runtime by its name. And this is something that working with C++ and some other languages you do not usually do, or like in C, for example. Because you have the POD data, you have like floats in your struct and different other fields in your struct, and you get used to the fact that you have to actually get a struct and change its property by doing like dot property name and changing it. And in Unreal, it's possible to actually just give the system a name of the property, and they say, okay, if the property of this name, fname, exists, how about you go ahead and change it? Or you could get it and take it out of the system. And it's nice because it allows you to do some nice, some kind of, I would say, useful and elegant, for example, character stat generation systems, where you have, for example, inventory, and inventory has items, and items can affect certain stats of the character and not affect other stats. And that's where actually I myself encountered the use of this stuff. But let's just dive straight into it. And I have my project right here. Let me make it like this so you can actually see it. And I will just go ahead and say new C++ class. Let's make it a pawn class. Yeah, let's call it my pawn, we don't really care. Create class. So now it's compiling the module. The compilation will be fast because we don't have any code in our project. And here we are, our pawn. We don't need tick, of course. Input component we don't need as well. Let's just make sure that we are loading the game with our pawn, because we will not be doing any gameplay programming today. It will be more like a kind of more deep way of looking at programming, I would say, like Unreal programming, I mean. And the reason why I'm making this tutorial is because I couldn't find any tutorials on this. Maybe, if you know the links, you are free to add them in comments. I actually found information about this stuff in the comments for the Answer Hub question. Okay, so we need to make a game mode so we can actually say that, use the pawn in our scene. So let's just call it really in a very primitive way. Again, we're compiling. Hot reloading thankfully works more or less fine. Successfully must compile before the module appears. Fail to automatically hot reload, doesn't really matter for now. Yeah, that's actually fine. Let's close this guy. I'm using Visual Assist, so there will be some errors there. Okay, so of course we have these things so couldn't find it. Okay, so what we will do is we will add a property to our pawn. Let's add two properties to our pawn, and then let's make two functions as well. One of the functions will read a property by its name, and the name will be given in blueprints. And the other function will change the value of the property by name if this property exists. So let's go ahead and let's try doing it. First, let's just make two properties and see that they work in game. So new property, let's expose them to blueprints and to the editor. So let's say edit, let's say edit anywhere, blueprint, let's do blueprint read only, so that we cannot change them in the blueprint, so we'll have to use our function. And let's say like float prop1, something really basic, and it equals 0 by default. And just Ctrl+C, Ctrl+V another one, call it prop2. Let me make my code bigger. Okay, so now we have these guys, and let's see that they work in the blueprints. I'll start the compilation of the project. Should be fast once again. And we're done, actually. Really nice. Actually, I'm not used to having this fast project compilation because I'm working on the project which has like much more code. Okay, so we can play on this map, it's fine. We will just need to override the game mode with our my game mode base. And actually, you know what, let's make a blueprint out of it. And call it in a really, really bad way. And the reason why we're making blueprints is because we don't want to write extra code right now, so that we don't waste time. We would have to, sorry, if we were writing C++, we would have to go into the CPP of the struct, of this guy, and change there the classes, but we can just do it here. So default pawn class will be our my pawn. I think that's the guy. And then of course let's also make blueprint for the pawn so we can test some stuff. Let's not call it my pawn, let's call it my pawn BP. And again, just in the root folder. Again, this is not how you make how you structure your project and how you name your stuff. This is just a demonstration. Okay, so we have my pawn here, and you can see we have two properties. And let's do the thing. On begin play, we will just say print string, and in the string we will do get prop1, and then let's also print prop2. Okay, and next, actually, while I'm doing it, I realized something, that the method that I'm gonna show you, it works for UStructs, and I believe these are not UStructs. UStructs are the ones that you define with the UStruct macro, and these are like C++ structs but with Unreal reflection system. So we will change it a little bit. Sorry for my misdirection there. It's after a long day, actually. Okay, so let me quickly redeem myself. Let's create a UStruct right here. Struct, let's say f prop struct. F is something that is Unreal convention for structures, and let's say generated body, because for UStructs you need generated body. And so we just take our properties out of my pawn, add them to the struct. Because it's a struct, they will be public by default, but blueprint read only, so same idea we had before. Now let's now here have blueprint read only thing, where we do f UStruct So we'll have a reference to this guy. And let's just quickly compile this thing. So now we have a property in our pawn, which is just references this structure by value, or stores by value. Okay, so now we don't have prop1, prop2, but what we do have, we have prop struct. And now prop struct we can break, and we have prop1 and prop2. Okay. And we can actually store some stuff here. So let's make sure that prop1 is 17 when we start game, and prop2 is 34, and we're printing those guys. So when we start our game on this map, we don't get anything. And the reason why we don't get anything, because our pawn is the default pawn, right? It's not my pawn. Yeah, it's default pawn, which is fine. Yeah, because we should use my pawn BP right here. And let's see, I think that's the guy. Alt P. Okay, so you can see it prints in the top corner 17 or 34. I also suggest you do the same thing that I'm doing, which is you have output lock on your screen when you're programming a lot in C++ especially, because here you will see the output lock. So you don't have to always look at the top corner and, you know, maybe you will miss the message or something. So this is really nice to have here. So 1734, just like we expected. Okay, so how do we change those things? Well, let's dive into the world of reflection really quickly. Okay, so let's make a method for this particular property, for this particular structure. Let's call it change. Let's start with get. Get float prop by name, and it will return float, of course. Sorry. Nah, that's not good. Get float prop by name. So it takes two things, of course. Takes fname prop name. That's the first thing. The other one, of course, is float. Well, actually, no, that's the only thing, because we only need to get float prop by name. We could return success, of course. Yeah, let's do that, maybe. So boolean will return success or not success, and float will be the output if we found it. So you could discard the second parameter if it did not find the thing. Okay, so again I'm using Visual Assist, so I can just do this quick hotkey, and I'm going to the C++ file, CPP file, and it already made an implementation for me. But if you don't, just do it by hand or use some macros. Okay, so what do we do first? Well, first, because this is a UStruct, we can get access to its singleton UStruct object. So here we go. It's an object of class UStruct. We just call it UStruct. And it will be fPropStruct. It has static struct method. So we need this guy to actually access the properties of the singleton object. It's kind of, as far as I understand, it's kind of like a CDO, class default object, but for UStructs, and it allows us to get access to the properties by property names and addresses. So you have a UStruct here. Let's try to see if we can find a property now. So let's just call it, first of all, it has a type U property, again by pointer. So prop, and then we say, okay, inside this UStruct, let's find property by name, and we have prop name here. Okay, so this is the first time you would check. So if property actually was found, then this will be truthy. So if no prop was found, you just return false. You could also do check to throw or ensure, but let's do it this way. So if not prop, then return false. And then we have to get a address of this property in our struct. Because remember, this is a class method, or in this case structure method, so you can actually go and take address. So this will be a void pointer, so it's just a pointer to the memory address. Struct address, let's go this way. So given this property that we know now that is not null, let's do container pointer to value pointer. And just the type is void, we don't care about the type. And now we give the struct, so it will take the address of this property in this struct. And of course we are in ourselves, so this will be, we will give this, so ourselves. Okay, so we're not checking this, but we'll check the next thing, which will be uFloat property. Remember, we want to change the float property or get the float property in this case. And so let's cast our thing to uFloat property. We could actually do this here. I'm using Alt to move my line of code. So we check that property exists. Now we check if it's float property, if it is a float property. Otherwise, we just return false. If it is, then let's go ahead and read it. So how do we read it? Well, let's read it straight into the output. And then we say, okay, you know what? Float property. Get floating point property value. And now we give the struct address that we just received by giving it our struct. Okay, so if this happened, return true. Okay, so let's really quickly compile this thing. Let's see if our code is correct. And it's not, because I'm actually using the wrong registry there. Let's do it this way. Meanwhile, you can return, okay, sorry, you can remove extra stuff here so it doesn't kind of take space. Begin play, you don't need. Okay, so it worked. Now let's just give let's create a method which will operate on our pawn, which is fine, and it will just go ahead in this property structure, which we can give to it by value, and it will get the values by the name. Okay, so this will be a function, of course. I have actually a micro for this, which I called UFC, not the mixed martial art tournament, but the micro. And it has category, let's say, category prop struct. Okay, if you are wondering where I got these macros, or snippets as they're called in Visual Assist, just look up Visual Assist. It's really, really handy. It's kind of like a sharper for C#, but for C++ and really, really useful in Unreal. Okay, so this will be a function which will return floats. Let's say get float from our fprop struct, and what you give to it is of course fprop struct by value, and it will also return boolean, you know, was it successful or not. Not return, but you give it boolean by reference. When you give references to functions which are exposed to blueprints, in blueprints they will be as outputs, unless it's a const reference. If it's const reference, then it's input, of course. But I think you cannot use const references here, because Unreal would say, like, what are you doing? Okay, so we have this guy. And now let's see, bool success equals, now we just say struct, get float prop by name. And I forgot, by the way, we need to add fname here. Again, I could do this by hand to add to definition declaration, but I could just say here, change signature, this is visualize this thing. And here we'll say fname will be the first or second argument. Okay, let's keep it the first argument. Prop name. Okay. So no magic. It did the same thing that you would do by hand by now. Okay, so get float in prop by name, prop name. And then of course, let's have a float here, float result. Okay, so, oops, I did something weird. I called bool. Let's call it success. And visualizist automatically renamed references. Oh, no, visualizist did not. Okay. Bool success. Bool success. Maybe it was my fault, I'm sorry. Success. This is not, you're not helping visualizist. Okay, so success equals struct and writes results here. Nice. Struct get float. Prop by name, so this is fine. So now we just return result. So let's see if this works. No, it doesn't. Yeah, because, okay. Look, visualizist, I'm sorry that this happened. I don't even remember whose fault was it. So that's, you know, the lesson for you. The automated tools do not always help you. Okay, so we have success and hot reload completed, I think. Man, this is fast. Okay, so nothing changed here, hopefully. Alt P, 34, 17. Okay, nice. So now let's play a game where we cannot actually use print string. We have to do something else. We cannot do this guy, but what we can do now is get float from prop struct. And our prop is called prop1. Remember, in the editor you will see spaces like prop space 1 or white space 1. Keep in mind there is no space. It's prop 1, prop 2, no white space. So here when you give prop names you have to do prop 1. Okay, so let's print string here, depending on whether it was successful or not. If it wasn't, let's do something like failed. And if it was, let's just print the value. Boom. Alt P. 17.0. So it works. Nice. Okay, so let's quickly finish this up. Actually, it's already 23 minutes. Damn, time goes fast. So first thing first, this thing doesn't change anything. So it makes sense that you make it const. If you make it const, it will be automatically blueprint pure, so it doesn't have execution node. But it calls this guy, so this guy now has to be const as well. And because you made them all const, you have to go ahead in the source file, const. Okay, so now let's see, I think it will tell me what I should fix to make sure that everything is const. Let's see. Okay, yeah, so this pointer should be a const pointer. And that's it. Okay, hot reload is complete, and look, now it's just a node without execution because it only prints or returns stuff, sorry. Okay, so it returns 17, and now look, cool trick. Let's say it's a prop 2. Alt P, 34. If I do something weird, like whatever, some weird property name, it says, well, you know, failed in the top corner. You could see it there. Okay, so again, let's wrap this up right here. I did not show you how to set properties, but if you remove const from this function, you make a similar function, call it set float prop by name. You could just do like float prop set floating point property value. So again, you give it struct and then you give it value. So this would work as well. Now, aside from float values, there are like uVector field, for example, and some other fields as well. So, or uVector property, I think. No, maybe it's vector field property. So you can actually go through. Oops. Okay, that's me pasting blueprint node. Okay, so what you can do, of course, you can go to uFloat property, and then this file contains other stuff. You see double property and bool property and so on and so forth. You can change all of that. This function doesn't have to be actually bound to the particular UStruct. You could make it a standalone function, I believe. Let's see, do we have any binding? No. It will just have to know the... It will just have to have access to this UStruct singleton object. So you could pass it and, you know, have any UStruct or any, pretty much any UStruct you could change using this method. So again, setting values there is pretty much the same. This is one of the things that I discovered today. I hope this was useful because I couldn't find this tutorial about this stuff anywhere. So please leave your comments, tell me what you think, and see you later. I'm hoping to continue my lightsaber combat tutorial series in the near future. So stay tuned for that. Bye bye.